Today's lesson is the gradient of a line, part 1. So there'll be a part 2 coming. The gradient of a line or interval is a measure of how steep the line is. Okay, it can measure it by number or an angle. Okay, it is represented by the variable m, little m, and is the ratio, fraction of the vertical rise to the horizontal run between any 2 points on a line. Okay, that's what the definition of gradient. Remember, we had a capital M for midpoint, but gradient is a little m, so don't get confused about those two symbols. Let's have a look at gradient. Gradient is basically how steep it is. So if I look at this car going up the hill here, so you see that the angle on the triangle there, put it as a theta here, the angle, that can be my gradient, how steep it is. Or what we're doing today is measure of gradient in terms of number. To do that, we need rise over run. So gradient equals rise over run. So my rise is going up, which is y-axis. It's a vertical. So if you think about the number plane, the going up part is the y-axis, okay, the vertical line. And the run is the horizontal line, which is your x-axis. So all you need to do is you count the spaces going up and then going to the right. So you do need to form a right angle triangle to find gradient. Oh, what if my car is going down the hill? That's also gradient, but it's going to be negative gradient. So the car was going up is a positive. Now, can you see that this car is going up and it's on the right hand side, and that's a positive rise. But what happens if it's going down? It's on the left hand side. Okay, can you see that it's a left hand side here, and that's negative rise. Let's have a look at the summary of that. Now, also remind you about right angle triangle. The names opposite to the right angle and the longest side of right angle triangle is called hypotenuse. That's important because hypotenuse is representing the gradient. In terms of a road and the right angle triangle, you'll be riding on the hypotenuse. That hypotenuse is the road. So flat road, if you're walking or driving on a flat road, there's no steepness. So therefore your gradient is 0% or 0. And then if you're going uphill, that means some steepness happening, isn't it? So it's going to be higher gradient. For example, 10%, 20%. Downhill road, it can be very, very steep as well. But because it's going down, it's a different direction. So it's a negative. So one is going up, that's a positive. One is going down, which is opposite direction. It's called negative. Negative and positive. And also another one is a 0 gradient, which is the flat surface. Now, just for your interest, how did I find the percentage of the gradient? What I've done was just find a gradient and times by 100 gives you a percentage. In terms of a number plane, how do we find the gradient? I put interval. Remember, interval is the part of a line that has a 2 end points. Interval AB on number plane here right now, and I need to find the gradient of this interval. So what I need to form a right angle triangle with that interval. So that's what I did. This one is my right angle triangle right now. And why do we do that? Because we want to find how many spaces for rise, how many spaces for run in order to find the gradient. Because a gradient is rise over run. Which one is my rise? Rise is going up. So that means this one, my y-axis. Okay, my y-axis says it's going up by 1, 2, 3, 4. So my rise is 4. my run is my x-axis, which is here. Okay, so you can count it on x-axis. So you can do that. 1, 2, 3, 4, 5. My run is 5. But think about this, guys. This one is going towards, the interval is going towards your left-hand side, isn't it? It's a negative gradient. Step 1, we need to decide whether this interval is negative or positive gradient. It is negative. That gives us negative rise. So instead of writing a 4, I need to write a negative 4. But my run is always positive. So there's no negative and positive. So it's always positive. Rise is a different. If an interval is going towards your left, you have negative rise. If it goes to your right, it is a positive rise. So my gradient, the symbol little m, equals negative rise over run because it's going towards my left. So I'm just going to write my 4 here and my 5 here as my rise and run. So my gradient is negative 4 over 5. So this is summary of what I've been talking about. The gradient of a line or interval, it can be a line, but what we've just saw was interval. M equals rise over run. And rise is my vertical line, so that's why it says vertical. And the run is my horizontal line. So when it is actually going up or going to your right-hand side towards it, it's called positive gradient. But the line or the interval is going down or it's going towards your left, it means you have negative gradient. So let's have a look at the example. Calculate the gradient of each line. Now you can see it says it's line, not interval, line. How can we tell it's a line or not? It doesn't have end points. It has 2 arrows going each end. That's when you say line. But if it has an end points on each end, that means it's interval. How am I going to find the gradient of this line? First step is I have to find out whether it's a positive or negative gradient. Now, this is going towards my right-hand side, isn't it? So it's going to be positive. It means it's going to have a positive rise. Now I have to decide which one is my rise, which one is my run. My rise is the vertical one, okay, going up, and my run is the flat horizontal one. Rise is 2, and it's just 2 because it's a positive. And my run is 6. The gradient, little m, is a rise of a run. So therefore, my gradient is 2 over 6. And also, this one can be simplified because the numerator and denominator are even numbers and they can be halved. So half of 2 is 1, half of 6 is 3. Simplified gradient is 1 over 3. The next one, let's have a look at this line. It's going towards my left. Therefore, my gradient will be negative. That means my rise will be negative rise, minus 8, negative 8. My run, it doesn't really matter because there's no negative or positive. It's just 4. And my little m, which is my gradient, is rise over run. So I'm going to go minus 8 divided by 4. Okay, we need to simplify this. Minus, what's half of 8? 4. Half of 4 is 2, and I can still simplify this further. I'm going to halve this again. What's half of 4? 2. Half of 2 is 1, and you know that we do not write 1 on the bottom as a denominator. So my gradient, little m, equals minus 2. It's okay to have a 1 on the top as a numerator, but not for denominator. All right, now we have 2 points. So that means the gradient of intervals. Okay, so we got two intervals. Each one has two endpoints. How do we find the gradient of those? Let's have a look. Now, first step, before we're jumping in, whether it's a positive or negative gradient, we need to plot them first. We need to see which way this interval is going towards. It's going to go towards the left or towards my right. That'll decide whether it's going to be positive gradient or the negative gradient. So let's plot them. Point A is -4 and 2. To the left from my 0, which is here, to -4. So it's here. Okay. And then going up by 2. So my point A is right here. And then my point B is 4 and 6. So I'm going to go to my right 4 spaces, and it's here, and going up by 6 right there. So that's my B. Now if I join them, because I want to see whether this interval is going towards your right or left, it'll look like this. Okay, and it'll going towards my right. It's going to be positive. Okay, so that means it's going to have a positive rise. So my rise is going up 1, 2, 3, 4. For my rise is 4, and because it's a positive gradient, just 4. And my run, I'm going to count it. 1, 2, 3, 4, 5, 6, 7, 8. It's going to be my 8. Now my gradient is rise over run. So it's going to be 4 over 8. And this is not quite finished because we need to simplify this further. So I'm just going to halve it. It's easier to just halve it when it's like even numbers. But if it's odd numbers, you need to think about which families belong to. Like it could be a family of 3s or 5 or 7. Sometimes you can't simplify, so leave it as it is then. So what's half of 4? 2. And half of 8 is 4. And I can still go one more time, isn't it? Because 2 and 4 are still even numbers. I can simplify. So half of 2, 1. Half of 4, 2. Now, 1 is on my numerator, so I can leave it as it is. If it was on the denominator, I don't count it. So that's my gradient for this interval. Okay, next one. I have 2 points. C is -2 and 4, and D is 2 and -4. So -2 is here, and I'm going up by 4. 1, 2, 3, 4, right there. That's my C. And with a D, I'm going to the right by 2 and going down by 4. Also up here. So that's my D. Now, if I join them together, it'll look like this. I have to decide whether it's a positive or negative. It's going towards my left, so that means it's going to be negative. Second step, I need to find my rise and my run. Now, my rise will be negative rise because it's negative going towards my left. So let's have a look at my rise. I'm going to count this. 1, 2, 3, 4, 5, 6, 7, 8, and it's going to be -8. Now, before I count rise and run, you need to really create right angle triangle with the 2 points. Okay? In this case, points C and D. And then you can count your rise and you can count your run. My run is 1, 2, 3, 4. And then next, last step, finding my M, my gradient, rise over run. So -8 over 4. And I can simplify this. My negative stays until the end. You know, you can't get rid of negative, okay? So half of 8, 4. Half of 4, 2. And I can keep going until I cannot simplify further. What's a half of 4? 2. Half of 2 is 1. So what happens here? I have denominator as 1. We don't count it. So my gradient, my final answer will be just minus 2 because I don't write over 1. So first step was you're plotting them and you decide whether it's a negative or positive gradient. In this case, it was negative. And then form the right angle triangle. And then I'm going to count the spaces for rise and the run. And then I'll find my gradient. All right, that's all for today's lesson. Well done. Thanks.